Okay guys, the last video we did, we talked about how to write the equation of our parabola given the parameters that we know for the focus and directrix. Now when we're given those two pieces of information, the focus and the directrix, obviously as you saw in yesterday's video, it's kind of a difficult thing. Because the problem is very long, you use a distance formula and it takes a while. But if we're given information like the focus and the vertex, or the directrix and the vertex, basically we're given the vertex as well, this becomes so much easier. You're going to be surprised basically at how simple these problems are today. But they're going to be easier if you're familiar with the vertex form for horizontal and vertical parabolas, which is why we spent so much time the other day covering those things. So if you're familiar with your vertex form for vertical and horizontal parabolas, this will be perfect for you. We're only going to introduce one new feature to those equations, okay? And that feature is going to be called P. P is going to be a parameter that we use that discusses the distance from the vertex to the focus and the directrix. So we already mentioned that the focus and directrix are equal distance to any point on our parabola, including the vertex. So their distance from the focus is going to be the same distance from the directrix. It wouldn't matter either way. They're going to be the same distance. But if we know what that distance is, we're going to use it, we're going to be plugging it in for P in our little vertex form of our equations. So you can see that here. Here's what we'll do. We're going to start by looking at problems that are where the vertex is at 0, 0. Okay? Then we'll do problems where the vertex is not at 0, 0. But it's not much more difficult, but it is a little more difficult, those problems. But anyway, you can see the equation. This is technically vertex form, in a way, for a horizontal parabola. You know it's a horizontal parabola because it's x equals, right? And you know this is a vertical parabola because it's y equals. We talked about that the other day. Now you don't see the h or k in this vertex form because remember we're talking about the vertex at 0, 0. So h is technically 0 here, and so is k. So that's the reason you don't see them in those two formulas, or those two equations. Okay? But, like I said, later in this video, or in a different video that I'll do, we'll actually see the h and k because we won't be at 0, 0. Alright, but anyway, the only difference that you see here is p. P in the denominator. Remember, p is going to represent the distance that the focus and directrix, or directrix, are from the vertex. Alright, and as long as you know what that distance is, we'll just plug it right in, and that's pretty much it. We'll be done with writing the equation. The equation will be done. All we got to do is plug in that distance value for P. Okay? Alright, one thing to keep in mind though, and this is kind of important, the directrix is x equals negative P or y equals negative P, depending upon vertical or horizontal. So remember I said vertical is y equals, so if it says the directrix is y equals, that tells me it's going to be a vertical parabola. Vice versa for x equals, we said it's horizontal if x equals, and the directrix is x equals. That's our indicator that's a horizontal parabola. But the thing I really want you to point out is that P is technically going to be a negative value in this case. So if we're given the directrix, we're going to make the P negative. If we're given the focus, we're going to leave the P positive. That's kind of important, okay? So remember that. If we're given the focus, the distance we're going to use is as a positive value. If it gives us a directrix, we're going to use that as a negative value. All right? So you'll see what I mean when we try a few of these problems out. So write the equation in standard form for the parabola. All right. So first and foremost, look at our parabola and tell me, is this a vertical or horizontal parabola? Well, it's opening downwards. This is a vertical parabola because a horizontal one would open sideways. So it's vertical, which means we're going to be using the equation y equals 1 over 4p x squared. Alright, and again, now all I need is to know the value for p. And I have both information here. I have both the focus and the directrix. But remember what I just said? Pick one of them. If you pick the focus, leave the p as it is. If you pick the directrix, do the opposite of that p, or take the negative version of p. So let's say we wanted to use the directrix, right? Y equals 5. Well, remember, if we use the directrix, then we need to make the opposite of that value, okay? And now we're using this one because it's y equals. We're using the opposite value. So if directrix is y equals 5, then I'm going to be using negative 5 for p and plugging in negative 5, okay? So that's all we'll do. We'll just plug in negative 5, y equals 1 over 4 times negative 5, x squared, which, if you simplify, is y equals 1 over negative 20, or we'll just call this negative 1 over 20, x squared. And that's it. We're done. Okay? Oh, don't worry about that. That was a mess up. But anyway, we're done. So remember, P is just the distance between the vertex and the focus, or the vertex and the directrix. So you notice here our vertex was 0, 0, and how far away was the directrix? It was 5 units. How far away was the focus? It was 5 units. So that's why we're plugging in 5. But we do have to be careful because sometimes we'll have to plug in a negative 5. Sometimes we might have to plug in a positive 5. It depends on the problem. But that's why I mentioned before, if you're going to use the focus, keep the P as it is. If you use a directrix P, then the negative would change its sign, basically. All right? So that's going to be the only trick is when are you plugging in a negative number, when are you not? And here's another way you can verify it. Notice our parabola opens down, right? Which means the A value should be a negative number. So keep that in mind. You should realize, hey, you know what, my answer should be a negative A because the parabola is indeed opening downwards. That's another way you can sort of quickly check your answer. Alright, so let's just try this again. See if it comes to us a little better. This time we don't have the graph, but if it helps, sometimes visualizing the graph is pretty useful. Well, let's try to do this without visualizing the graph, and then maybe we can look at one and see how we did. See what it might look like. Alright, so in this one, I'm given the vertex at 0, 0, okay, which I told you we were going to do that already. Directrix is at x equals negative 6. Now, am I using the horizontal vertex form, or am I using the vertical vertex form? Well, because this is x equals, remember x equals is a horizontal, alright? So that means I should be using that equation x equals 1 over 4p y squared. Okay. Again, I know I've got to use this one because x equals is sort of my giveaway that this is going to be a horizontal parabola. Alright, the directrix is negative 6. What did we say before? Going back to this. The directrix, if we're given the directrix, we need to change the sign and use our P. Okay, so first question I'm going to ask you is, if the vertex is at 0, 0 and the directrix is at negative 6, how far away is it? Well, it's 6 units away, right? So we're going to be plugging in 6 here. But do we plug in 6 or do we plug in negative 6? That's always kind of the give. That's kind of the catch here. Well, remember, if it gives us the directrix, we have to change this sign. We got to do the opposite of what we see. So we're going to plug in a positive 6 for p. And so our equation will be x equals 1 over 4 times 6, y squared, which will be x equals 1 over 24, y squared. Okay, so again, p is the distance, and since this is 0, 0, the directrix is at negative 6, if you visualize this on a graph, vertex is 0, 0, 0, directrix is at x equals negative 6, which would be right here. Alright, that would mean our parabola would look something like this, you know. And you can see it is 6 units away, so the p-value is going to be 6 and or negative 6. But why is it positive? Well, if you visualize this parabola, you can clearly see that it's opening to the right, and opening to the right is positive. So that's just another way to check. Alright? Okay, so this one, again, the vertex is at 0, 0, and directrix is x equals negative, x equals 1.25. So, first and foremost, it's x equals for my directrix, which means this is a horizontal parabola. So I know I'm using this equation. All I need to do is know what p is. Now, the vertex at 0, 0, The directrix is at 1.25. So how far away is the directrix? Well, we know it's 1.25 units away. But now the catch is, do I plug in negative 1.25 or do I plug in a positive 1.25 for p? And again, since it's giving us a directrix, remember the directrix, we have to change the sign for p. So if it's a positive 1.25, we are going to be plugging in the negative 1.25. We'll have x equals 1 over 4 times negative 1.25 y squared. And that would be what? X equals 4 times 1.25. 4 times 1 is 4. Is it 5? Is it 1 over negative 5 or negative 1/5? I think it is. Alright, and then that's our equation and we're done. Alright? So again, here's, guys, I guess, in conclusion, how I would summarize this. Because it is sort of a bit of a jumbled mix. Hey, the positive is the negative. What am I doing? In summary, know the distance immediately. That's your main thing. You want to know how far away is the directrix from the vertex or the focus from the directrix. How far away is that? Because that's your distance. Okay? And that's essentially what you're going to be plugging in for p. The only catch that there is sometimes you have to change the sign for the number that you were given or the distance that you know, make it negative. Sometimes you have to leave it as positive. And how do you know when to do that? Well, if you go back all the way to sort of this piece of information, if it tells you the directrix, then you change the sign for the p-value, the distance that you're using. If it's telling you the focus, you're going to keep it the way it was given. So I don't know. Let's see if there's an example here that gives us the focus instead of the directrix. Alright, you can see our example, negative 1/5 y squared. Alright. So no, it doesn't. The next thing it talks about is when the focus, or I'm sorry, when the vertex is not at 0, 0. I'm going to end this video here, and then I'll do those problems in the next one. So, see you in a bit. Bye-bye.